Hello, welcome back to Op Amps. We're talking about integrating amplifiers, and we have a simple problem on the board. Actually, it's a little simpler than some of the other ones we've done. I could have actually flipped the order of some of these problems, but that's okay. I want you to be exposed to different types of situations. So here we have an op amp, same configuration. We have the output over a 5.1 kilo ohm resistor. We have a feedback capacitor, half of a microfarad. And then we have an input resistance resistor, but we don't know what it is, so we're calling it R. And then we have a voltage source, a constant 4 volts, positive 4 volts, and we have a switch that closes at t is equal to 0. That's when we start the clock, right? And so then it tells us at t0, the energy stored in the capacitor is 0. And it tells us that saturation is reached at t is equal to 15 milliseconds. And then this last part is the question: what is the value of this resistance R? So there's two or three pieces of key pieces of information for you to understand, and you just have to make sure and understand all of them, and then you can just apply the integral formula and we'll get to the answer. First thing is it's telling you that at t is equal to 0, the switch closes. So when we do our integration, we go from t naught, that's going to be 0 in this case, up to t, so that's what that means. It's a positive 4 volts going into here. And it's telling us that the energy stored in the capacitor is 0. When you see something like that, if you go back to physics and look at the energy storage in a capacitor, that's related to the voltage on the capacitor. So when you see that there's 0 energy stored in it, that means there's no voltage across it. So they could have just told you the voltage across the capacitor is 0, but they didn't. They told you the energy stored inside is 0. Same exact thing. It's just teaching you the different terminology. So we know that when the switch closes, at that moment in time, there's no voltage across this capacitor, and therefore that means that this V out here is 0 at that initial point in time t0. And then it's telling us saturation is reached when time marches along by 15 milliseconds. That's when saturation is reached. But look at your power supplies on your op amp. You have a positive 5 volts and a negative 5 volts. So big picture, before we do anything, you got to kind of have a general roadmap. You don't have to have the details, but a general roadmap. We're going to write an output equation for the output of this op amp. It's going to be an integral from 0, because that's t naught, 0 up to t, right? And we're going to integrate this input signal, which is a positive number, over that guy, and then we're going to add the initial condition, which we now know is 0. There's 0 volts in the initial voltage on the capacitor. So we're going to write that relation, we're going to do the integration, we're going to get a relation. Then we're asked, or we're told, that saturation is reached here. So then you have to decide, because you're going to end up using the equation to figure out what this value of R is, which value here is it going to saturate at? Is it going to be positive 5 or negative 10 volts? And you can figure that out without even doing anything, because you know that this is an inverting amplifier. I mean, it's exactly the same thing as if a resistor was up there, in the sense that it inverts the output.